Okay, so we need to find the vector equation of the line passing through A, 2, comma, -1 and 5, and the perpendicular intersects the line. This perpendicular intersects the line whose equation is x minus 3 equals y minus 1 over z. So again, I hope you recognize that vector equation of a line, there are two types. There's a vector equation of a line of two types. One is a vector equation, one is a Cartesian equation. So Cartesian equation is in this form in terms of x, y, z. Okay, next all you need to do is to reduce the shortest distance from A to L. So everything before we do is good for us to try to draw it out. So we have a point like L, and this is L, and L is x minus 3 equals to, okay, so before that maybe you go to x minus 3 equals to y minus 1 over 2 equals to z plus 1 over 2. Right, and passing through A is over here, and A is 2, -1, comma 5. Right, so this line passes through A and is perpendicular and intersects the line L. Right, so this maybe let's call this line 1, and let's call this maybe line 2. Right, so we need to find the vector equation of line 2. So remember, when we find a vector equation, first we need we need a direction vector at a point. And so to find a direction vector, what we can do is we will to use probably, let's say if I want to use maybe first find M. Alright, and maybe what we can do is the next strategy is we try to find AM. Okay, because AM, right, will give us the direction vector of line 2. Right, you give us the direction vector of line 2. Next up, alright, so what we do is how do we find first AM? We need to find AM. We can first find OM. Okay, so from here, maybe what we need to do is we need to first find OM. OM using, what do we use? We use line 1, because we know that OM lies on line 1, so actually OM can be written in terms of equation of line 1. Okay, and after that we try to find AM, and then we find with AM we can find the direction vector of L2, and we find the equation of line 2. Okay, so let's look at line 1 first. Okay, so line 1, right, looks like this x minus 3, 1 minus 1 over 2, and z plus 1 over 2. Okay, so this doesn't look very helpful, and for the time what we can do is, most of the time to solve any meaningful question, we always need the vector equations, right? So quickly, for L2, right, this just means that, okay, I'm going to leave it to do it by yourself. Your vector equation of line 1, okay, let me just write this properly. Okay, now line 1, right, the vector equation of line 1, this is equals to 3, 1, -1. Okay, so you can say 3, 1, -1. Okay, plus lambda of 1, 2, 2. So you can see 1, 2, 2, right? Okay, where lambda is a real number. And from here, right, you have the vector equation of line 1. So that's more meaningful. You know that, okay, because OM, right, lies on line 1. So since OM lies on line 1, that means OM, right, can be equals to 3 plus lambda, 1 plus 2 lambda, -1 plus 2 lambda, right, can be written in this way, right, for some lambda. Okay, and next up, if we can find OM, we can also say that AM is actually the same as OM minus OA, right? It's the same as 3 plus lambda, 1 plus 2 lambda, so this OM, right, subtracting OA. OA is 2, -1, and 5. Okay, that will give you eventually, you just end up with 1 plus lambda, 2 plus 2 lambda, and -6 plus 2 lambda. So this is how our AM looks like. Okay, so this is how our AM looks like. Okay, so we also know that AM, right, this is perpendicular to, remember that this is perpendicular. So what does it mean? This helps us to find AM. So we know that AM dot product with the direction vector of line 1, right, should be equals to 0. Okay, so very quickly, 1 plus lambda, 1 plus lambda, 2 plus 2 lambda, negative 6 plus 2 lambda, dot product with the direction vector of the line, and the direction vector of the line is nothing but 1, 2, 2, should be equals to 0. Right, so 1, 2, 2 comes from here, right? 2, 2 comes from here. Okay, so after that, quickly we have 1 plus lambda, plus 4 lambda, minus 12 plus 4 lambda, equals to 0. So 1, 4, 8, we have 9 lambda. 1, 4, 5 minus 12, we have negative 7, plus 9 lambda equals to 0. And lambda should be equals to 7 over 9, right? And this means that our AM will be equals to 1 plus 7 over 9. 2 will, okay, then 2 plus 2 lambda, so it's 14 over 9, negative 6 plus 2 lambda, okay, 14 over 9. AM should be equals to, okay, quickly, it's just 1 over 9. If I take out 16, 32, negative 40, okay, or if I factorize, having a good habit of always looking for common factors and factorizing, I have 8 over 9, 2, 4, negative 5. Okay, so quickly, AM, what does AM give us? Remember that AM give us this is the direction vector of L2, right? So this gives us the direction vector of L2. Okay, so very quickly, equation of line 2, right, is equals to 2, negative 1, 5, right, the position vector of A, plus mu, right, we don't use lambda anymore because we used it just now, right, and 2, 4, negative 5, right, so 2, 1, negative 5 came from here, right, 2, negative 1, 5 comes from here. With that, over here, mu is a real number, and that's the equation of line 2, okay, the line that passes through A and is perpendicular and intersects the line 1. Okay, very quickly, how do we find a shorter distance? The short distance is none other than, easily, right, the shorter distance, right, it's just AM, right, it's just AM, okay, then it's just 8 over 9, we know that AM is, just now it's 8 over 9, 2, 4, negative 5, right, so just 8 over 9, square root 2 square, plus 4 square, plus negative 4 square, right, that will give us, eventually, 3.